Then in the training, in the classical training of botanists, even today, they do emphasize the ability to represent what you can see. So a lot of our undergraduate training is sitting in the lab, looking down a microscope, drawing what you're supposed to see. And so this is this training of spatial perception. And some people really get very good at it. This is a very prominent South African botanist. That's his own illustration. That's in your typical kind of scientific style, stripped down. It's not trying to be a artistic representation primarily, but it is artistic. Okay, he has a feeling for those organisms and for layout and whatnot. In this case, executed in black ink on white paper to sort of catch that precision. But it doesn't have to be as austere as that. There's another famous South African botanist. He's now retired, Professor Stanley Seagrief, and he's like the world expert on seaweeds, especially around the South African coast. And all of his books are illustrated by himself. Okay, so a person who has the ability to do that in both fields. This particular one I really love. So Harry Bolus is the person after whom the Bolus Herbarium at the University of Cape Town, one of the biggest and oldest herbaria in Africa, is named. And I always thought that he was the prof of botany until I started doing research around this particular one and found, in fact, he wasn't a botanist at all. He was a stockbroker. He was, in fact, the founding stockbroker in South Africa when they created, very appropriate here in the Standard Gallery, actually. He sort of founded the stock exchange in Cape Town. But like many people in that kind of business, he had a secret passion, which was plants. And so he made money on the stock exchange, but what was really his motivation in life was plants. And it was his own collection which formed the foundation then of the Bolus Herbarium and his bequest of money to run it going forward. And that's why it's named after him. But you can see that he was not only interested in plants, but he was actually a very fine artist as well, not just an illustrator, although we can see this is not a painting of this particular orchid in the wild. It's a painting of this orchid presented for storage in a herbarium, where you take the specimen and you fold it so that it will fit onto the page. Okay, so that's what he's doing. He's representing a herbarium specimen, but he's capturing its coloration and whatnot. What I love about this is its Art Nouveau elements. You know, if you look at this and the time it was painted, the little, like the lettering he uses and this little device of, he allows the things to transgress the borders. Okay, it's such a modern touch, and it's such an Art Nouveau touch that's coming through in that what was intended to be a scientific illustration. So here's a trick question: who painted that? Okay, it's a fritillary, which is a painting, a flower which occurs in England. And this was painted by someone who is famous in a actually completely different domain. But he spent the latter part of his life doing this. He stopped doing what he was later became famous for. He wasn't famous so much in his own life, okay, but later he became an absolutely seminal figure, but he stopped doing that quite young and spent the rest of his life, in fact, painting flowers in this really very interesting style. Oops, I don't want to move on. And that was who it was, a guy called Charles McIntosh, who was one of the key originators of modern architecture. That's his most famous, and in fact his only building, I think. I think he actually in his life only had 2 of his buildings built, and this is the most famous one. It's the Glasgow School of Art. It still exists. It is an amazing building. He's also famous for his detailing. So he not only designed the buildings, but he designed all the detailing within them, and in fact all the furniture. And what you probably know him from is chair design. You know, if you walk into any top-end furniture shop in Sandton, you will find chairs inspired by Macintosh. It's those ladder-back chairs. You will know them immediately. So that's what he's famous for. But his, what he spent, in fact, most of his later life doing was botanical art. And I think you can see, in fact, some of those things coming through. And of course, he was a hugely influential figure in the whole Art Nouveau period. And Art Nouveau is totally based on floral designs. Okay, that whole asymmetry, the whole sort of curlicues and whatnot, is entirely inspired by plant designs. So architects, it seems, are people whose brains really work in a synthetic way. They not only have a kind of a spatial vision and an artistic vision, but they also have to have a very analytical sense about how to build these things and so they don't fall down and kill you. And this is one who was really way ahead of his time. This is Antonio Gaudi. That's the internal column structure for the Basilica of La Sagrada Familia in Barcelona, which I think is just one of the most marvelous buildings ever done. It was started in 1882. It's not finished yet, okay? It's only going to be finished, they think, in another decade or two, but in fact, it's the most amazing thing. So the reason I put this picture up is not only to illustrate this absolutely beautiful, beautiful design, and this was explicitly founded on trees. Okay, so columns up to that stage, if you trace the evolution of the column as an architectural element, had actually come from bundles of reeds. So you can go back into Egyptian temples, and you can actually see them evolving from the earliest ones, which were quite explicitly bundles of reeds, okay, with a kind of the papyrus sort of fronds at the top, which is that curly stuff at the top of the column, and then watch that evolve through the Greeks, where those became stylized into flukes and little Corinthian tops and whatnot. So, the original kind of wooden buildings which preceded those stone buildings would actually have had bundles of sticks or bundles of reeds tied together, supporting the surface, and then they translated that into stone. And he's taken that one further in saying, no, I'm looking at the structure of a tree as supporting this roof. Now, the problem here is this had never been tested. So the way cathedrals were built through the Middle Ages is you built it and it fell down, and then you rebuilt it a little bit stronger, and that's how they found out, how to do these things. This had never been done. And so he had an ingenious way of working out what those angles and what the sizes should be. And if you ever go to Barcelona, go into the museum there and see it, what he did is he said, all the forces from the top here are gravitational forces operating downwards, okay? And I'm going to simulate that by turning the whole thing upside down and putting little stones on ends of pieces of string and see how they naturally settle down in space. And then he put a mirror underneath that and looked at it from the other side. Okay, and that's how he came up with this design. It has only been possible to solve this mathematically within the last decade. So this was being solved on supercomputers using finite element analysis, and he's absolutely right. Okay, it's perfect, it's strong enough to beat it. But he took that inspiration from looking at the way trees, in fact, design their structures to support their canopy. So how do trees do that? Okay, so this is a root structure rather than a canopy structure, but the same thing applies. They don't have a supercomputer. Okay, it's not evolutionary super smart to do it by trial and error. So what trees do is each individual wood cell actually is sensitive to the tensions and the compressions in its environment. And if you have a part of the tree where there is compression occurring, what happens is you put on something called compression wood. And so that part of the tree grows until that stress is alleviated. If you have a part of the tree which is under tension, like a branch hanging down or something, it will put on tension wood where there's tension until that stress is alleviated. And so it's a self-correcting engineering problem. It kind of adapts to its environment. And if the environment changes, if you put that tree in a windy place, for instance, it will morph itself such that it can balance those forces. And that's essentially what Gaudi was doing with his little strings experiment.